Hello everyone, welcome to Think Then Code. Today we'll be solving the problem palindrome pairs. Given the list of unique words written all pairs of the distinct indices I, j in the given list so that the concatenation of two words, that is words of I plus word of j, is a palindrome. Quite a straightforward question. Okay, so we are given an input words and we have to return every possible ij which are indexes such that words of I plus words of j will form a palindrome. Okay. So one of the naive approach to solve this, that is very brute force approach, is we can do a big O of n square loop. So for every word, we can check every other word in our input array and concatenate them and check whether the concatenated word is a palindrome or not. So this will have a time complexity of big O of n square if we are assuming that n is the size of the words array, and if we are assuming that k is the size of every word in our word array, then it would be n square into k, because we also have to check the palindrome, and for every word we are checking every other word in the input array. So it would be n square into k, but this is a very huge complexity, so we have to reduce it. So to reduce it, let's first understand one analogy. So what I want to say is a palindrome is formed of three strings. First is left, second is mid, and third is right. Now, what do I mean by this? What I mean by this is these left, mid, and right are three strings, and when we concatenate them, we form a palindrome. But how? Let's take it with an example. Example, we have a palindrome. Let's say A, B, C, D, D, C, B, A. Since this is a palindrome, now how we would break it into three strings? First, left can be ABC, mid can be DD, and right can be CBA. You can also break it into another ways, but this is one possible example. Also, one more statement I have to make it clear that if a palindrome is broken into three strings, left, mid, and right, then the left string is the reverse of the right string and the mid string is a palindrome itself. For example, here we say we are having three strings A, B, C, D, D, C, B, A. A, B, C is reverse of C, B, A and D, D is a palindrome itself. So what does this, the conclusion of this entire analogy is, if we are having one string that is left and if we are having another string that is mid, which is a palindrome, what we can do is we can reverse the left, generate another string that is right, and by combining left, mid, and right, left is reverse of right and mid is also a palindrome itself, we will be able to form a new palindrome. This is the statement which I want to make. So how does this help in our question? Let's understand. Now let's assume we are traversing the string. We are traversing our input array, that is word array. And we are having a string, let's say str1. Now this string combined with another string str2 forms a palindrome. So target is to find this str2. Okay. So if we see, if this str1 and this str2 is forming a palindrome, and a palindrome is equal to left plus mid plus right, so we can also say that str1 plus str2 is equal to left plus mid plus right. Or since we are traversing the array, we are currently having str1. So if we are currently having str1, str1 can be two things. Either it can be left plus mid, or it can be mid plus right. Now how? Let me explain it. Let's say we are having str1 as the same example, abc dd. So if we break it into two parts, the first being left being abc and the mid being dd, since the mid is a palindrome and the left is abc, what we have to do is we have to just search for reverse of the left. And what is reverse of left? It is right, which is cba. And what we have to do is we have to search cba in our input array to get str2. So str2 will be right. And if we reverse that, if the str2, that the palindrome is starting with str2, so it will be str2 plus str1 is equal to left plus mid or mid plus right. And if it is the case, then our str1 can be mid plus right. And if our str1 is mid plus right, we can again find mid. We can always find such mid, which is a palindrome, and take the remaining right, reverse it, and find it in our array, and which will be the left part of the palindrome. I hope you got the explanation. Let's understand the code. So this is the accepted code. Instead of this, let's see this code because it is a bit commented. This is the same code as the accepted code. So first what we are doing is we are having a palindrome function to check whether the substring starting from L and ending at R inclusive is a palindrome or not. So we run the loop. It's the standard palindrome stuff. Now what we are doing is we have to perform a search. So to perform a search, we are introducing a hash map here. So we are creating a hash map of size MP, and we will store indices of the strings in this hash map. Second, we are having answer, and this is empty index. So for example, assume we are having some empty string. For example, this is the empty string. This empty string can form a palindrome with any other palindrome. So if we combine empty string with a palindrome, what we get is a palindrome itself. Also, this can be reversed too. That is, a palindrome with an empty string will form a palindrome. So we have to return all these permutations of empty string with a palindrome also. So that's why what I have done is, for empty string, I have initialized a variable empty index. Since every word is unique as given in the question, that is given the list of unique words, even if there is an empty string, it will be just once in an array. So that's why I have created a single variable, and then I have created a vector of index of palindrome. So we'll keep checking whether there is a word is a palindrome or not, and if it is a palindrome, we will add its index in this vector. This is the part where we fill the index of palindrome vector and our hash map also. So if it is empty, we fill the empty index variable and continue. If it is a palindrome, we fill it in our palindrome array, and this is the variable which we create to fill in our hash map, and we are reversing it. So why we are reversing it? I will explain it a further statement because it is a type of an optimization which I will explain further. Now we come down. We are traversing every input array, that is every word in our input array, and we are cutting that word. For example, if we are having a word, let's say A, B, C, D, E, F, what we are doing is first we try to cut it like this, like A is the left, B, C, D, S is the mid. Then we cut it like this, A, B is the left, C, D, E, F is the mid. Then we cut it like this, that is A, B, C is the left, D, E, F is the mid. Then we cut it like A, B, C, D is the left and E, F is the mid. So what we are doing is we are running a loop, say cut, for the size of the array, that is the size of the word which is given to us. And then we have two cases. Our current string can be either left plus mid, or our current string can be either mid plus right. So if our current string is left plus mid, as we show here, if it is a mid, so mid should be a palindrome. As we discussed earlier, mid will be a palindrome and left will be the reverse of right, or right will be the reverse of left. So if we are assuming our current string is left plus mid, then what we do is we traverse. This is the part where we check that is mid palindrome or not, because our left part of the array is 0 to cut minus 1, index is inclusive, mid is cut to words dot size minus 1. So with this indexes, we check whether the substring of this index is a palindrome or not. If it is a palindrome, we create a variable named as right. Now, since we know that right will be the reverse of left, so we have to reverse this right every time we are encountering a situation that mid is palindrome. But every time reversing right is an expensive operation. So instead of reversing every time right, what we did is we reversed the word which was given to us and then inserted in the hash map. Because words are only having a size of n, where n is the size of the input array given. But the substrings, which is this, that is right, can be of a complexity n square. So reversing them will take more time as compared to just reversing the hash map inputs. So we create the string right. We searched in our hash map which contains the input words which are reversed in order. So if we find it, we check whether it is not the same as our current index or not, and if it is not same as our current index, we insert it in the answer. In the same way we do for mid plus right. If our current string gives mid plus right, we check whether mid is palindrome or not. This statement says that mid is palindrome or not. If yes, we search for left, and if we find left, we check whether left is current index or not. If it is not, which means we found the answer, we push back in our answer array. And at the end, we check whether there was an empty string in our array or not. And if there was an empty string, we have to fill all the combination of empty string plus palindrome and palindrome plus empty string. So we traverse this loop which contains all the indexes of palindrome, and finally we return the answer. So what is the time complexity of this approach? Let's understand. If we assume that k is the size of words.i and n is the size of words array, then the complexity of is big of n into k square. Why? Because we are only running a single loop for input array word, and then this cut runs k times because we are getting every substring of the word given. So that's why k square. So the time complexity is k square and the space complexity is big of n because we are creating a hash map. I hope you like the approach, and if you do, please like and subscribe. Hope to see you in the next video.